4.1, graphing quadratic functions. So this lesson's all about how to graph parabolas. Like we did a basic version before, but now we're gonna do go really in depth in parabolas. So first, a quadratic function is a function where the highest term is x squared, or y squared, or whatever. The highest term is a squared. So if you have this quadratic function here, you can see that's a quadratic term, don't want the x squared in it. The a, b is a linear term, and c is a constant term. We call those functions parabolas. The graph of that function we call it a parabola. So first, like I always like to do, let's see what this looks like. And the first time I always do it with a table. Say your calculator does it. Right, by default, when you put your calculator to do something, graph something, it just makes the table really fast. So we're going to go 0, 1, 2, 3, 4. Right, so with my x's, I plug it in. Plug in 0, I just get 5. If I plug in 1, 2 times 1 squared minus 8 times 1 plus 5. That's this one. I get 2 minus 8 plus 5, negative 1. Yeah, okay. Plug in 2. I get 4, I get 8 minus 16 plus 5, so negative 3. Plug in 3, 9, 18, 18, I get negative 1. Plug in 4 and I get 5. Yeah, I kind of knew that. Anyway, we graph it. 2, negative 3, so 1, 2, 1, 2, 3. Oof. 0, 5, probably should start there. There's 0, 5, and then 1, negative 1, and then 3, negative 1, and then 4, 5. And you get this parabola. That's a bad graph, but that's the idea, parabola. So I want to point out a couple things. First, this point right there, which in this case is 2, negative 3, that's called the vertex. It's the start of your graph. So if you ever do a table, you always want we're gonna find a vertex a lot first, and you always want that to be the middle of your table. So if you make a table, make that the middle. And we'll say this is h and k, that'll make more sense later. So that's the vertex. Another key point, when you cut your graph in half at the vertex, there's a line that does that. We call that line the axis of symmetry. If you see it, it's the exact same thing as the x in the vertex. Is that x equals 2, which is the same thing as the x in the vertex. It's always going to be true. The x in the vertex is also the axis of symmetry. And there's one more thing I want to point out here, and that is the y-intercept. So there's a y-intercept right there. It's always easy to find. Remember the way we found that y-intercept? You set x equal to 0. There's actually x-intercepts here and here. We'll deal with solving those later in this chapter, I should say. X-intercepts. So those are the key things. When we draw a parabola, like with all the bells and whistles, we're going to need the vertex, we're going to need the axis of symmetry, and we're generally going to need a y-intercept. And then we can draw a nice parabola. Okay, so let's talk about the shortcuts of doing that. So right here. Alright, so if I give you a normal parabola, a normal quadratic graph right here, a couple of things. If you want to find the y-intercept, like we always talk about, right? Y-intercept, just set the x equal to 0. Here's the big one. If you want the axis of symmetry, we have a formula for it. Axis of symmetry is x equals negative b over 2a. So if you want to find axis of symmetry, if you have the general equation, you just use the formula negative b over 2a, and that gets you the axis of symmetry. Why it's so important? Because when you have axis of symmetry, you also have the x in the vertex. So for your vertex, it's just the x value is negative b over 2a. The way you find the y value is just plug it in. Right, anytime you have an x value, you want to find the y value that goes with it, just plug it into the formula. So a lot of times you see it written like this in a book, say f of negative b over 2a. That just means plug it in, right? Plug your x value in. So when you see that, that's all that means. Plug it in. So those are the key things, right? If we want to find the vertex, negative b, if you want to find axis of symmetry, negative b over 2a. If you want to find the vertex, well, negative b, that the x symmetry is also the x value. Plug it into your equation to find the y value. And if you want to find the y-intercept, set x equals 0. So let's graph a couple doing it that way. So here's our equation. They want to find the y-intercept, the equation of the axis symmetry, and the x-coordinate of the vertex. Well, these are the same thing. So we're going to do that. Let's do the y-intercept first, because that's what they asked for. We set x equal to 0. Plug in 0, that goes away, you just get 5. So I get x equals 5. Sorry, you plug in 0, and so you get y equals 5, also known as the point 0, 5. So that's my y-intercept. Now let's find the axis symmetry. Alright, so that's x equals negative b over 2a. Remember the way this works? Here's my a, coefficient, here's my b, here's my c. So x equals negative 8 over 2 times 2. By the way, if you haven't noticed, this is the exact same one we just did, but now I'm doing it using the stuff we learned. So axis symmetry is x equals 2. Now let's find the vertex now. So I already know the vertex has 2 and something, because it's axis symmetry, exact same thing. So we just plug it into the equation. So 2 times 2 squared minus 8 times 2 plus 5. This is 4, so 8 minus 16 plus 5. Negative 8 plus 5 is negative 3. Negative 8, yeah. So negative 3. So that's my vertex. Now, this thing says make a table of values that includes the vertex. So again, if I was to do that, I'll do the exact same I did here. Where make a table, make the vertex in the middle. I actually don't care about having like the most accurate graph. I just want the general, I want this stuff. I want the general concept stuff. So if I was going to graph this, I'll use all my information. My vertex is 2, negative 3. My axis symmetry is at x equals 2. And then I have a y-intercept at 5. There we go. Then when you draw it, I just try to make the two sides match, right? Because that's what axis symmetry does. So I want to hit this way and try to do the exact same graph on this side. And that's my parabola. That's how that works. Let's do another one, a brand new one, so we could talk about it. So same idea. I want to find the y-intercept. Set x equal to 0. Again, just some plug in 0, and that goes away, you just get negative 1. So my y-intercept is at 0 when I plugged in, and negative 1. Let's find the axis symmetry. X equals negative b over 2a. So my a here is negative 1, it's a coefficient. So it's not, you never just put x, it's always just the coefficient. So it should be a number. Here b is 6. And then this is my c, negative 1. So in this case, I get x equals negative 6 over 2 times negative 1. Negative 6 over negative 2, or just 3. So my axis symmetry is x equals 3. Then my vertex. Right, so again, I have the x value already. I just got to find the y value. So we're always just plugged into the equation. Three, so make it sure. Okay, remember this goes first, so it's 9, and then the negative's on the outside, so negative 9 plus 18 minus 1, that's 9 minus 1 is 8. So that's my vertex. So now if we're going to graph it, ooh, let's have a, I always forget I have shapes here. Make a grid. There we go. Now if I want to graph it, I just got to go 3 and 8, so 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Right there. Axis symmetry is 3, so I'm going to draw a little dotted line right here. Right, so always the x on the vertex. And then my y-intercept is 0, negative 1. So it's like this. So if I graph it, it's going to be opening down of all things. Ooh, that should be more curved. Oh, that's an ugly graph. But anyway, opens down. So I wanted to point that out. Look at this one's opening down. The one we just did is opening up. You know what the difference is and why that's going on? It has to do with your A. Positive A has a parabola that opens up. A negative A has a probability that's opening down. That's what we're talking about next. So if you look at these two, the one that opens down has a maximum point. This is the highest you could reach. So when A is negative, you have a max. Right? Can't get any higher than that point right there. When A is positive, you open up. So you have a minimum point. So when A is positive, a min. And that's leading to our next thing. So how do you find the max and min value of something? Well, they're just the vertexes, right? There's my min, because again, when A is positive, you have a max. When A is positive, sorry, you have a min. When A is negative, a max, because it opens down. So if you want to find the max value, max or min value, all you do is find the vertex. Now when I say that, so let's say this point right here, just to give an example, let's say that point is 0, 7. What's the max? It's actually not, it's not 0. A lot of people think it's the x value. It's the y value. The max or the min is the y value. X value is where it happens at. Where the max or min occurs. So keep that in mind. So if you want to find the max min, just find the vertex. The y value is actually what we're looking for, because that's how high and how low it is. So that's your max or min. And then the x value is where it occurs. Sometimes I might ask you like a word problem and say, when does it happen? The x value. So let's look at problems where we have to find the max and min of equations. So this problem right here. Determine that what each function has a max or min value, and then find that value. State the domain. Again, we're not doing that yet. So look at this one. A is negative. So it means an open down. This has a max. If I want to find it, let's just find the vertex. Remember, the way you find the vertex is negative b over 2a. I only have an a here. This is my a. But I don't have a b. There's no x term. There's no constant term. So they're both 0. So in this case, I get negative 0 over 2 times negative 6, which is just 0. You notice that. Okay, and then that's my vertex, right? My vertex is 0, blank. Plug it in. So you plug in 0 into the equation, you get negative 6 times 0 squared, which is just 0. So I get 0, 0. So my max is just 0, the y value. Which you kind of know already. Like, we should know this graph. That graph is a parabola that starts right here and opens down. Right? It's a negative, opens down. It has like a slope, it has a vertical stretch of 6. So there's that one. Let's look at the next one. Same idea. Oh, it's positive. So it's a min. So we got to find the vertex now. X equals negative b over 2a. This is my a, this is my b, this is my c. So I get negative 8 over 2 times 3. And I get negative 8 over 6. Oh, how lovely. So that's the x of my vertex. That's where it happens at. I want the actual max. I need the y value. I got to plug that in. So it's going to be y equals 3 over negative 4/3 squared plus 8 times negative 4/3 plus 5. Get all that, and that is your max. Right, that looks ugly. Now you can actually do it. It's not too bad. It's like you actually square this, you get 16 over 9 times it by 3. And you get 16 over 3. Over there you get negative 32 over 3. Common denominator, so multiply this by 3 over 3, you get 15 over 3. And you're going to get 15 plus 6 is 31 minus 32, so you get negative 1/3. So it's doable, it's just a little ugly. But that is your max. And actually, sorry, in this case, your min. It's your min value. Right, so that's how I find the max and min. Now, if you notice, that was ugly, and I did it on purpose, because I want to show you how to do it on the calculator also. So another thing we can do on the calculator. We'll just do one of these. This calculator's not that bad. So the way we do this on the calculator, we're going to find a max and min. So step 1, type it into our calculator. So I got to bring up my calculator. There it is. So turn it on. Step 1, just type it in. So we're going to go y equals. And then we're going to type that equation in. 3x squared. Oops, sorry. Square button's right here. Plus 8x plus 5. I'm going to graph it. Now my window's off because this was using earlier. So remember, the easy way to fix your window, by the way, you can stop progress by pressing on. Just press zoom standard. So it looks something like this. Now the min is right here. Right? I'm trying to find the min right there. So how do we do it? Well, we're going to use our favorite button, which is second calculate. Second calculate, so there's value, there's 0, and then there's a min and max. So we're going to find the minimum. Now the way this works is like this. Let me show you over here. So you're going to give us a graph. And it's going to ask us for lower bound. So what you do is like, here's the min. So lower bound means just move your cursor until it's past that side. So it's over here somewhere. Or left bound, they'll say. Now, you want that to be your left bound. So what it's going to do is it's going to search in between something. So make that the furthest left you can search. It'll ask you for a right bound. So you're going to go past the min onto the other side. You make that your right bound. And what the calculator is going to do is it's going to search in between those two values you set to find the minimum. So that's what it's going to do. So that's the way it works. So see how it says left bound? I like to move to the min, so it's around there. Then move left a little bit. Then it says right bound. Go back to the min. Now move right a little bit. Hit enter. It says guess. Yes, hate it. Yeah, guess. Of course, guess. And then you get your min. Negative 1.3 or negative 4/3 and negative 0.3 or 1/3. There you go. The minimum again is the y value. So negative 1/3 or 0.33. The line over it. Now let's look at the 48 real quickly. So a couple things with 48. First of all, it's a max. So look at the A. Remember, your A is always, this is your A, that's your B, that's your C. A is always the thing with the x squared, not the way it's positioned. You could rearrange this. That's your A. So again, it's a negative, so it's opening down. So it's a max this time. Let's do zoom real quickly. So y equals, took me a while, negative 16 minus 14. Notice again, I put a negative when it's the first number in the thing I'm typing in. I put a subtraction sign what's in between things. Then minus 12. X squared. Hit graph. Now I want to show you this on purpose because when I graph it, I don't see anything. This graph is not a normal viewing window, so I got to fix my viewing windows. A couple ways you could do it. You could zoom fit, works for some people. Ooh, where's it at? Let me scroll down. Zoom fit tries to fit it in for you so you could get a nice view of it. But for me, that doesn't work always the greatest. It's not that bad. So you have zoom fit. You can always go zoom standard. And then zoom out so you can see it. So you can hit zoom and then you can hit out. And you can decide where you want to zoom out. Hit enter. And it's not working with me right now. Zoom out. It usually lets you decide where you want to zoom out. So then you press enter and it zooms out. You can kind of see it. And you can zoom in again, I guess. I'm going to go back to zoom fit because that worked the best. Sorry, zoom fit. I didn't mean to disparage you earlier. So there you go. This is my zoom fit. And then we're going to find the max. So go second calculator. Maximum. And again, all you want to go. So it's kind of hard to see where it's at, but look right here. That tells you where it's at. So right now it's like at almost 0. So it's like right here. Right? That's 0. So I'm going to go low left. You can move until you see it if it helps you. It's like right there, you can see it. That's definitely left of the max. And you go right. Now, if you press second and arrow, it goes faster. But here's just, you just hold it down. So you want to go right of the max. And then you put guess. It finds your max for you. Negative 11.9. That's my max. Again, it's the y value. X value is where it happens at. And there we go.